Okay, Ruby, let's read example 1.
Use the diagram below to write an expression that could be used to find the area between the graphs of f and g on the interval ABM.
So what I want you to do is take, for me, I'm going to use my blue, and I'm going to run over the upper curve. And with my pink, the curve on the bottom. And here's a formula that's going to work out every single time. So here I have, our integral is actually happening from, we're going from A to B. So let's have we're going to integrate from A to B. My upper curve is going to be our f of x. Here's our f of x. Minus the lower curve is going to give us the value right in between, g of x. And this is in terms of x dx. And the way I like to kind of look at this is the following. This is our height. And dx is change in base. So what I'm going to actually have you guys draw every single time is going to be some skinny rectangle. Where do you make the rectangle doesn't really matter, but I'm going to just pick a point on the top and the bottom and make a rectangle. It could be wider or skinnier, doesn't really matter as well. So imagine that little ruler scanning between and finding the area between, okay? So we have the height times the base will give us the integral between from A to B. And there's a reason behind dx on here. Do y'all see from A to B is the direction of the x's? Yep, that's what the dx is. So if we go in the direction of the y values, that's going to be dy. But for that piece, we'll do on the second example. So on the next page, let's do number 1 as an example, which is already part of your homework for tomorrow, right? Or Monday, Tuesday. So we have the instructions on there that I'm really not going to worry about. So let's worry about graphing these real quick. The first one that I want to graph is y equals x minus or x plus 1. Y'all remember graphing back in Algebra 1? We have our y-intercept of 1. We go up 1 over 1. And if I were to connect this, I have a linear function. And go all the way down. Questions on this part? Good? All right. The second one, what kind of graph would that make? If something is x squared, it makes a u. So is it going to be upside down u or the normal u? Upside down, because it's got a negative. So in general, it's going to look like this. So our y-intercept is at 9. So let's go to our 9 on the y, put a dot. So what is 1 squared? So that means I'm going to go to the right 1 and down 1, left 1 and down 1. What is 2 squared? 4. So I'm going to go from the vertex across 2, down 4. And then left 2, down 4. And let's do our last point. What is 3 squared? So I'm going to go from the vertex across 3, down 9. Left 3, down 9. Then that is enough for us to make our parabola. So make it pretty. Not like a V, but more like a U. So I feel like we're doing Algebra 1. Okay. And then our next two parts. It says x equals negative 1. So x equals negative 1 is going to be right here at the vertical line. And then I have x equals 2, another vertical line. So now I'm going to shade in right in between. And before I do, let's use our usual color. Blue for the top curve. I should really say top equation because the next one is not a curve. And then pink for the bottom equation. And if I were to take those 4 equations and bound them, the area that we are going to shade is the area we're finding. And I want to do a little guesstimation on this one. I want you with the neighbor to count about how many square inches, well not inches, units, will that kind of give us? Go ahead and count those whole pieces real quick. What's up? Go, go. We're gonna kind of do a little estimation. Was it locked?
Yeah, it was locked.
Start counting the squares. If you think you have an approximation, give me a number. 19? Anyone think above or below that?
I got above. I got like 21.
21?
I like 19.
19? What is your 19? 19 point what ish?
I have no idea.
You know, I would do 19.1, so it's going to take over everything above that. Okay? All right, so let's see if that's a good approximation. So our formula on this one, I'm going to circle. My top one was in blue. My bottom curve or the line was in pink. And because our x value is changing from -1 to 2, this one we like to call it with respect to x. That means when I make the rectangle, I'm going to have a vertical rectangle. So let's make a rectangle and see if we can make a vertical rectangle. So here's our vertical rectangle. And when something is with respect to x, that means everything is in terms of x. So when I write the equation or the integral, I should see everything with the x and no y's. So let's see if that is true. Integral from -1 to 2. My upper curve is 9 minus x squared. And here's a common mistake that we get all the time. When I subtract the bottom curve or the bottom line, you have to put this in parentheses, x plus 1. Because in the end, you're distributing the negative to them. Then we have dx. So do I have all of mine in terms of x here? Yeah? And I like to think of this one as the height times the base. And when the rectangle scans it, it's going to give us the exact value. So go ahead and grab a calculator. See if I have one. If you have a class set, go ahead and grab one. Everybody, get your own out if you have as well. And let's see who is more accurate between 19 and 21.
Wait, why did you draw a rectangle right there?
Right here?
Yeah.
Imagine a rectangle being a ruler and scanning, depending on the height, it's going to give us the exact value of the area of that region. It's like a little scanning tool.
You can draw anywhere? Yeah.
Anywhere you want. Yeah, as long as I'm using the top and the bottom. Put it in the middle if you want.
Will it all be an overestimated? Will it go over?
It's going to give you the exact value.
Okay.
So I see what you mean by this one. I kind of drew it too wide, you know.
Okay.
All right, so how do we find the integration symbol on the calculator? Math, what was it? 9. And we're starting from, no one caught this one. That was -1. So we have -1 to 9. And let's put in our equation 9 minus x squared minus the parentheses of x plus 1. And let's put dx. And let's see who was more correct. 19, 19.1, or 21.
Are you supposed to put 2 at the top instead of
2 at the top.
the integration?
The integration, it should be 0, -1 to 2.
Yeah, you put 9.
Did I put 9? Oh my God.
Oh, I got it.
Silly me. Who caught that first? Okay, that's gonna be your point. Thank you.
Okay, I was gonna say mine. I don't know.
Thank you, Jameson.
Put it in.
Like, how did you-
So we know the exact area under that curve, or bounded, is 19.5.
These are just like the equations.
So it looks like, Sam, you won, right?
Yeah.
Yeah,
What do I win?
you won,
No, I won that.
yeah, you did.
What do I get?
Tap in the back. All right, now let's do one that's gonna be with respect to y. So if with respect to x is top minus the bottom, what can we conclude about with respect to y?
Bottom minus top?
The right minus the left. Bottom minus the top. Okay, so on the back, I want to look at example 2. And I don't care about this first one. I just care about the second drawing. So I want to go ahead and highlight the right piece. I have a horizontal parabola. And then we have a linear function on the left. So because they're horizontal, I need to go ahead and solve for x. So when I do, we get the following. We have, because it's going to be right to left, this is with respect to y, meaning everything will be in terms of y. Okay, looking at this equation, to make x by itself, I can move the x over, keep the 3 where it is, and minus y squared on both sides. So I did 2 things at the same time. If you want to show the process of that, go for it, but I'm not going to. For this one, to make x by itself, what would I do? The only thing I need to do is what? Add 1 on both sides, so y plus 1. So I'm going to go ahead and write out what these specifically are from. This right here, this curve, is x equals 3 minus y squared. And then the straight line is x equals y plus 1. And let's use our formula. So go ahead and put a dot between from left to right. And you can put it anywhere you want. And make yourself a rectangle. How wide, it doesn't really matter. So we have the right minus the left. So my right side is 3 minus y squared minus, what do I need after that? What sign do I need? Parentheses. That's going to mess you up big time. And dy. So since this one's in with respect to the y, what is my lowest y value and the highest y value? We have -2 to the what? 1. And the way I like to think of this one is the left to right is the base. Change in y is our height. You don't have to write the base and the height every time, but I think it's good teaching purpose, so why not? Okay, on our calculator, I want some of you guys to use variable y all the way through, and I also want a few of you guys to use x on those. Let's see if we get the same answer. I'm going to use y, because I want to show you that it really doesn't matter. Someone bold enough to try it with the x? I'll do x. Could we actually type in another variable other than x on this one? Someone try it. Let's see if it works. Dx. How many do we get? 4.5? Did anyone try it with the y? I want to see if it works, just for the sake of it. This may only know the domain of x, so we shall see. Whoa, check this out. With the y, it also worked out. But I feel like x is easy to kind of find because the variable's already up here. So whichever one you like. So we have 4.5. Okay, questions on this? Good? So if you want to look at this right here, which is basically the same thing, top curve minus the bottom curve with respect to x, the right minus the left with respect to y. Okay? If that helps, that's good, but I want the highlighted pieces to be consistent throughout the whole unit. All set? All right.